Good morning, ladies and gentlemen. We are on page 185 of your student journal. And before we get started, today we're going to practice some more of dividing decimals. So my first problem is 1 1200ths divided by 8. So we've talked a lot about this in and out idea to help us remember. So the 1 1200ths is my divisor, it's going to go inside, and the 8 is my dividend. And the 1 1200ths is my dividend that's going inside, and the 8 is my divisor that's going outside. I apologize for that. Okay, so I'm going to set it up correct with my divisor and my dividend. Now when I look at my divisor, it doesn't have any decimal, which is good because we can't have a decimal in the divisor outside. So because there's no decimal, I don't need to do any loops outside, and because I didn't do loops outside, I don't need any inside. So all I do is bring my decimal straight up, and then I just divide. So 8 cannot go into 1. 8 can go into 12 one time. 1 times 8 is 8, and when I subtract, I get 3. 8 can go into 32 4 times, and 4 times 8 is 32. So my answer is 1400ths. Okay, here is your problem. 5400ths divided by 3. Okay, our goal today is, I will use the algorithm to multiply fractions. So we've been multiplying fractions using the area models to help us, but now we're going to actually multiply fractions using an algorithm. So a lot of times the algorithm is what your parents have been using, or if you ever hear people say, oh, the regular way to do it, it's not the regular way, it's just a different way. But it's usually a set of rules. So that's what this is explaining. The algorithm is a set of rules to follow. Okay, and we're not going to read through the rules, but it is a set of rules. And then they give sample story problems. I'm not going to be using story problems today because I want us just to focus on the actual algorithms. Okay, so here's our steps. We're going to change to an improper fraction if needed. So you have to use fractions only. No whole numbers. So no whole numbers. Okay, so the way that we're going to do that is we're going to, if we had 2 3/5, the way that we're going to change to an improper fraction is we say 5 times 2 plus 3. So 5 times 2 is 10. Plus 3 is 13/5, and then my denominator stays the same. And the reason that is because if I was to draw this, if I had 2 wholes and I had 3/5, so I had 2 wholes and I had 3/5, and I chose to cut up the 2 wholes I had, I would have 5, 10, 11, 12, 13/5. But instead of drawing it each time, you can kind of follow this. So you do the denominator times the whole number, so 5 times 2 plus 3, and then we'll be using the same idea. So step 1 is no whole numbers, so we're going to change to an improper fraction. We're going to use the algorithm rule. The algorithm rule is we just multiply straight across. And we're not going to be creating a story problem for these. Okay, so I'm going to get started. Here is my first problem. Okay, and my first one says 2 times 2/3. Well, 2 is not a fraction, so I need to change that into an improper fraction. So to change a whole number into a fraction, you just add a 1 under it. So 2 times 2/3. That's step 1. So no whole numbers. Step 2 is I'm just going to multiply straight across. So I get 2 times 2 is 4. 1 times 3 is 3. And you might have seen that this is the algorithm in the last lesson. You might have figured it out. Okay, so our answer is 4/3. But if I wanted to fix that because it's improper, I could use that in and out strategy and say 3 can go into 4 once. 1 times 3 is 3, and I get 1 and 1/3 because my denominator stays the same. So 4/3 is equivalent to 1 and 1/3. Okay, let's look at my next one. What is 1 and 2/4 times 1 and 2/5? Okay, so this one I'm going to actually write out because I don't like ever when they write it for me. It's too small. Okay, step 1 is no whole numbers, so I need to use improper fractions. So 4 times 1 is 4, plus 2 is 6/4 times 5 times 1 is 5, plus 2 is 7/5. So again, this is the strategy I use, so look back if you need that for help. Okay, so step 1 was no whole numbers. Step 2 is multiply straight across. So this is the algorithm. 6 times 7 is 42. 4 times 5 is 20. And that is my answer, but it's improper. So if I want to fix it, I can use the in and out strategy. So 20 can go into 42 2 times. And I'm getting, and I'm going to write that bigger, 2 and 2/20. 2 and 2/20 is equivalent to 42/20, but this is proper and this is improper. Okay, so let's try some together. We're on page 186, and here is our first problem. What is 4 times 1 and 2/5? Okay, so I'm going to write it first. Okay, so step 1 is no whole numbers. So this can just go over 1, and this is 5 times 1 is 5, plus 2 is 7/5. So we get 4. Step 2 is just do the algorithm, which is straight across. 4 times 7 is 28. 1 times 5 is 5. So that's our answer, but that's an improper. So if we want to make it proper, we can use our in and out strategy, and we get 5 can go into 28 5 times. 5 times 25. So our answer is 5 and 3/5 because the denominators always stay the same. So again, those are equivalent, but this would be the proper way to write it. This would be the improper way. Okay, let's look at our second one. We have 5/12 times 7/8. So step 1 says no whole numbers, so make improper fractions, but there's no whole numbers here, which means we can just go to step 2 and multiply straight across. 5 times 7 is 35, and 12 times 8 is 96. Okay, this isn't improper. 35 is smaller than 96, so this is already a proper fraction, so we could just leave it as is. Okay, ladies and gentlemen, you have the next couple pages to do on your own. Have a great day.